Okay, so we have a sine function again. They're saying there are numbers in front of the function and numbers in front of x, but they're not telling us what they are. What are the amplitude and period of the graph? Well, we've already seen, we practiced pretty recently, that the period is 2 pi divided by b. And I can't finish that because they haven't said what b is. And the amplitude is a. Or technically, the amplitude is the absolute value of a, because if there were a negative sign on this, we would throw it out. And I guess to be really, really accurate, I should have absolutes on here because I told you to ignore negatives in b as well. Determine values of a and b and write the function that this graph represents. Okay, so amplitude, we don't have an equation to work off of here. So for amplitude, I'm going to go back to our max minus min over 2. This wave tops out at 3. It bottoms out at negative 3. Divided by 2, the amplitude is 3. For its period, let's see, if it starts there, it goes hill, valley, and it's done by pi. So its period is pi. Now that's not what they asked for. They asked for the b value. You remember period is 2 pi divided by b, and we just found that that equals pi. Can you solve that for b? Take the reciprocal of both sides and you get, just flip it over, b over 2 pi equals 1 over pi. Then multiply both sides by 2 pi to get b by itself. Those cancel. Pi's cancel, and when the dust settles, we have b equals 2. Amplitude 3 and b is 2. Now, graph the function you just found and determine to 2 decimal places. We'll get to that in a minute. Let's just get it graphed first. Okay, so we said it's 2 sine 3x. And I'm just going to steal their window settings here. Minus pi by 2, minus pi. I'll go minus 3 pi by 2. That should be all right. Maybe a little more than they have, but whatever. And maximum 3 pi by 2, or maybe even 2 pi. Because this is half a pi, 1 pi, 1.5 pi, and then they go a little further, so we'll pretend it's 2 pi. Minimum, 1, 2, 3, we'll go to negative 4 just to give it some room, and maximum of 4. And if all goes well, cool. Okay, this looks reasonably close to what they have here. So we graphed it on the graphing calculator. Now they want the value of the function when x is 5 pi by 6. Well, putting in values is easy. You go second trace, and value is your very first option. What x do we want? We want 5 pi by 6, please. When we're there, y equals 2. And the values of x between 0 and pi, for which f of x is 1.5. This is going to take a minute. Okay, so the answer to the first one is 2, no problem. Now, they only want to look at x's between 0 and pi, so I'm going to scrunch down my window a whole bunch so we can just see the region they're looking for. All right. And they want to know where this function equals 1.5. So I'll just make another line that's exactly at 1.5, graph. And oh good, we get to find 4 points. There, 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 and there are all going to be solutions to the thing they're asking. To find them, you use second trace intersect. And we have to find these one by one. First it asks, is this the first curve? When you're finding an intersection, it wants to know what 2 curves you're talking about. So is this the first curve? Yeah. Is this the second curve, 1.5? Yeah. Where's your guess? And now we have to move the bug over to the intersection point we want to find. So the first one is 0.2827. They say to 2 decimal places, so 0.28 should do it for that. I encourage you at this point to pause the video and smash out the other 3 points yourself to make sure you know how. I'll just carry on and find them real quick. Intersect, blah, blah. And put the guess here. 0.76. Second calc, intersect, enter, enter. Let's see if that's good enough. 2.38. And finally, second calc, intersect, first curve, second curve. 2.86.